Mba633 instructional video prepared by Professor Amit Tata, School of Management, George Mason University. In this segment, we'll work a problem on hypothesis testing involving two population proportions. So the problem setting is the following. In Dallas, some fire trucks were painted yellow instead of red to heighten their visibility. During a test period, the fleet of red trucks made 153,348 runs, and at 20 accidents, the yellow fleet made 135,035 runs and had 4 accidents. Are yellow trucks less likely to have accidents compared to red fire trucks? So the two populations being compared here are red fire trucks and yellow fire trucks. The samples that we have here are yellow fire trucks in Dallas and red fire trucks in Dallas. Okay, so the question is, are yellow trucks less likely to have accidents compared to red fire trucks? So our first step, of course, would be to set up our hypotheses, and following our guideline, we want to set up our hypotheses in such a way that the claim that we are trying to establish should follow from the rejection of the null. All right. So let me write down the hypothesis that we are trying to establish, and I'll write it as the alternate. So are yellow trucks less likely to have accidents compared to red fire trucks? So let me phrase it the following way. Py is less than PR. So what does P mean? P represents the proportion of runs resulting in accidents, and the subscript Y is for yellow. So Py less than PR means we would like to establish that the proportion of runs by yellow trucks that ends up being in accident is less than the proportion of runs that end up with accidents for red trucks. So Py less than PR. Notice that this claim that we are trying to establish, we have set it up as the alternate, because if we go with the claim, that would result from the rejection of the null, since we are controlling for type 1 errors. Therefore, once we have set up the alternate, the null hypothesis, of course, is whatever is left over, which is simply Py greater than or equal to PR. So now that we have the null and alternate, you know that these two can be rewritten conveniently in terms of inequalities. So Py minus PR is less than 0. That's the alternate hypothesis, and the null hypothesis would be Py minus PR greater than or equal to 0. Okay, so all hypothesis testing starts with the assumption that the null is true as an equality, and in order to choose between these two hypotheses, the sample statistic that we would use is, of course, the difference of the sample proportions. In other words, P bar Y minus P bar R. So let us see what the sample statistics tell us. The sample proportion for yellow trucks in Dallas is 3 times 10 to the minus 5. Okay, so out of the 135,035 runs, they had 4 of them that resulted in an accident, and P bar Y, the proportion of runs that end up being accidents for yellow trucks, is 3 times 10 to the minus 5 approximately. The equivalent number for red trucks, the sample proportion, is 13 times 10 to the minus 5, and you can see the two sample sizes. N of Y is 135,035. N of R is 153,348. Okay, so the sample statistic that we are going to use for choosing between the null and the alternate hypothesis is P bar Y minus P bar R, which ends up being minus 10 times 10 to the minus 5. So it looks like there is a difference, but of course we want to know, is this difference large enough different from 0? Now that's where the sampling distribution of the sample statistic comes in. Now you know that if the two samples are large enough, then the sampling distribution of P bar Y minus P bar R will be normally distributed, and since we are assuming that the null is true as an equality, the middle of this distribution would be 0, because that's what Py minus Pr would be if the null were true as an equality. So the middle here is 0. Okay, and the value that we got from the sample, the difference between the two, is minus 10 times 10 to the minus 5. So the issue is this value, is this difference large enough away from 0? Is it far enough away from 0 for us to say, hey, it could not have happened purely by chance? Okay, so you know the routine for doing that. In order to compute whether this value is far enough away, we have to standardize it, and that will tell us whether minus 10 times 10 to the minus 5 is significantly far away from 0. And how do we standardize? I need to know the standard deviation. Now, the usual expression for the standard deviation of the difference between two sample proportions is this expression over here, that we've gone through this in class. So sigma of P bar y minus P bar r is P bar y times 1 minus P bar y divided by sample size of y, plus P bar r times 1 minus P bar r divided by the sample size of r. So you've done that before, but notice that in this case, the null hypothesis, we are claiming that it is true as an equality. All the analysis is based on that assumption. If the null is true as an equality, Py is equal to Pr, and therefore P bar y and P bar r are simply two different estimates of the same P. Okay, so in order to get a better estimate of what my P would be, I take the weighted average of P bar y and P bar r. So that ends up being my estimate of the population proportion, okay, the P bar. And I can do that simply because of my assumption that the null is true as an equality. So when you do the math, P bar ends up being 8.3 times 10 to the minus 5. So all you do is take this 8.3 times 10 to the minus 5, plug it in place of both P bar y as well as P bar r, because those two will be equal if the null is true as an equality. All right. So once you plug this 8.3 back into this expression with this for the square root with the P bar y and the P bar r, you will end up with 3.4 times 10 to the minus 5. So that's the standard deviation of P bar y minus P bar r. In other words, the standard deviation of the sample statistic. Now we have all the pieces that we need in order to see whether this number, this sample statistic that we got, is really large enough away, far enough away from 0. So let's standardize this. So z is equal to minus 10 times 10 to the minus 5 minus 0. I want to see whether this difference is significantly far away from 0, divided by 3.4 10 times minus 5, because that's what one standard deviation is equal to. This is what we just computed here. Okay, so how much do we end up getting for this value? Let's see. Be equal to minus 10 divided by 3, which is 3.33. So this is 3.33 standard deviations. So this value that we are getting, minus 10 times 10 to the minus 5, how far is it significant? It does certainly look that way, because this is 3.33 standard deviations below 0. But we can quantify how far what's the likelihood of getting this number. So I want the p-value. Now, what is the likelihood that I would be getting such an extreme value? And you know the built-in function that I have to use now is norm sdist of minus 3.33. And that ends up being 0.0004. So this is the p-value. Meaning, so again, you know the interpretation of the p-value. So what this is saying is, if the null were true as an equality, then there is only a 0.04% chance that I would be seeing a difference in the sample mean of minus 10 times 10 to the minus 5 or less. Okay, so remember, the p-value is the probability of seeing a sample statistic at least as extreme as the one you just saw, provided the null is true as an equality. Since this p-value is so much less than the usual limits that are used for alpha, you remember the narrative that we just had for this problem did not specify a level of significance, but you remember the two common values that are used for level of significance. One is 1% and the other is 5%. This 0.04% that you're seeing is less than both 1% and 5%. So I would be quite comfortable in rejecting the null. So even at the 1% significance, my conclusion would be yes, the yellow trucks are less likely to have accidents compared to the red trucks. So notice that the method that we have used to arrive at our conclusion is what is called the p-value method. So we computed the p-value, which is simply the probability of getting a sample statistic at least as extreme as the one you saw, provided the null is true as an equality. Okay, so that's our final conclusion, and you can work the same problem with the critical value method. In order to do that, you would have to first start from alpha, find out the z critical, that is how large a value of z would you consider extreme enough, and then compare it to the minus 3.33. Okay, so this is how you do hypothesis testing for two populations involving the population proportion.